Well, it is about 3 minutes after 11:30, so we're going to go ahead and get started. Good morning. Welcome to Boundary Systems weekly webinar. I'm Nicole Deringer from Boundary Systems, and today we'd like to present CADFix, Geometry Translation, Healing, Defeaturing, and Simplification. Today's presentation will be given by David Pickett, Technical Sales Engineer from ITI Global. ITI has been a partner of Boundary Systems for about 10 years now, and several of our customers use our products all the time in conjunction with Creo and Windchill. The ITI family does a fabulous job of making sure that our customers stay happy. And with that, I'm going to turn it right over to David and CADFix, and he will get you started. Thanks so much. David?
Thank you, Nicole, and thank you everybody for taking the time to join us today. Hopefully I was going to give you an insight into the opportunities that you'd have to improve your modeler interoperability with using CADFix, and hopefully you can also be able to see how easy it is to create good quality translations and the other opportunities you have for using your models for downstream usage and usability. So let me start by just introducing myself. I've worked for ITI now for 6 years as a technical sales engineer, 20 years experience in different guises of CAD, so that's as a user, manager, also selling CAD packages, training and support. So I'm located in the Cambridge office in England, where we do the CADFix development. And as Nicole said, I'm a technical sales engineer, so my role mainly involves visiting customers, doing demonstrations of CADFix, and also presenting. So a lot of our customers are involved with implementing initiatives such as model-based enterprise, product lifecycle management, advanced simulation, and digital manufacturing. And unfortunately, many times, when it comes to the interoperability, there's obstacles in the way that affect the implementation of these initiatives. So ITI have got a range of products specifically involved with helping overcome these boundaries, and specifically looking at things like conversion, integration, validation, and migration. Now, we're an international company, have the head office in the USA. I'm obviously based in Cambridge, where we do the CADFix development, and we have other offices in Germany and Israel. Now, CADFix itself is a facility for producing translations of CAD models and also combining these with healing and repairing CAD models where necessary. So we can read in either the native or neutral CAD files, do the work on them, then export them back to either neutral or native CAD formats again. So on the way through, what we're looking at doing is minimizing any work that you have to do in the downstream systems, whether that be the downstream CAD package, CAM, or other system that you're using. One of the key features that we use CADFix for is advanced simplification and defeaturing for the CAE processes. So CADFix has a range of imports available to it. We have a range of neutral formats and native formats, and specifically for the Creo users, we have the ability to import part files, assemblies, Creo view, and Granite files. And obviously on the neutral formats, we have all the key files there, such as Step Parasolid and JT Open. The third line there represents faceted formats and also some specialist formats for the analysis users. There are 3 modes of operation. There's the automated wizard, which everyone likes to use. We have the intelligent diagnostics for when something goes wrong with a model and it needs repairing. And then we have the fully interactive tools, which enable the users to launch individual tools and run those whenever they want. So on the way through, you're not only doing translation, you may be wanting to repair the model, doing some simplification such as removing holes and fillets, and then we'll be preparing the model for wherever it's going out to. So this is specific to the downstream system. So outputting the model, again, we have a range of native formats, including the Creo parts, Creo View and Granite, and we have some neutral formats, and again, the same list of exports we have available here. We have slightly more specialist systems we're going out to because there's more analysis packages maybe receiving our files. So as a Creo user, why would you want to be using CADFix? Well, there's 5 main reasons here. First one would be translation of data for data exchange. This may be going out to a CAD package, this may be going out to CAM, CAE, a visualization or digital mockups. Many customers say to us, well, they've received lots of files, but unfortunately when they read them in, there's some errors on the files and they need repairing. So again, CADFix provides facilities for this. For the CAE and analysis users, they want to do a lot of pre-processing on the models, and I'll show you some of this later. So some people specifically choose CADFix for doing this simplification. There's simplification for the IP protection, for your intellectual property, and there's simplification for the process plant and shipbuilding applications. This is a special case that's come up recently where people have a specific requirement to reduce all the detail off of design models to make them very simple and very lightweight for using very large assembly structures. And again, specifically for the Creo users, we have the ability to translate to and from native Creo files. So you can take NX files and put them straight into Creo, or you can export them out to something like Creo View. And we also have the ability to translate faceted models to and from Creo View. So this allows us to take in, again, faceted JT models, STL models, OBJ models, and PDF models, and then export them out to Creo View. Now, it's important to note at this stage, when we're talking about simplification, this is a model tree independent simplification. So whereas in Creo, you may be trying to remove a feature and it's dependent on a previous feature, that doesn't exist within CADFix. We can bypass that situation. And lastly, we have shrink wrapping abilities, so you can shrink wrap your assemblies into a single faceted model. So if we run in CADFix and we have the automated repair that we can run on models, this will typically repair 80 to 100% of the problems that you find in models. Now, this is using the intelligent diagnostic macro that runs through 5 stages within CADFix, and you can see these stages on the screenshot on the right. First of all, we're importing the model. We're then checking the model out and analysing the model to see if there's any errors in the model, because we want to make sure it's a valid solid. We then may optionally want to do some transformation processes. This is where the simplification comes in. So again, this could be removing holes, it could be joining surfaces together, joining edges together. Then we look at where the model's going out to, and again on the screenshot on the right, we've got Creo selected. So we'll be looking at the underlying geometry and preparing that geometry just to make sure that it's exactly right for the downstream system. And this just ensures that we've got the best quality model going out for you. Then we can export it out to the desired file format. When the models are in CADFix, you can see we have visualization of the model on the right-hand window. This displays the geometry and the topology. Model edges are color-coded, so this shows the connectivity. So a green edge is connected to 2 faces, which is good. And the idea is when we repair a model, we need a nice green model. If we have poorly connected edges with under the right number of connections, it will be displayed in red. If it's over connected, we'll then have yellow and blue edges displaying. Then the user tools we have is an automatic wizard, which I showed in the previous slide. We have a diagnostic driven repair shown in this image. And then we have geometry transformation tools available on another tab. The diagnostic fixing allows us to highlight the problems, as you can see on the top left-hand window of the image. This then lists the fix methods below it, and when we make a selection on the highlighted problems, it groups together all those problems into a single set, so the tools below only apply to that set. So this allows us to focus the use of the tools on only the part of the model that requires it. This ensures that we don't start upsetting the good pieces of the model. So if we scan a model and you end up with some issues coming up, this could be because the model isn't a valid solid, or potentially because we can't successfully export it to the target system for some reason. In this case, we go to the diagnostic window, and again the user is allowed to choose the appropriate fix method to match the required problem. And again, on the right hand side there, it's just allowing the user just to confirm that's exactly the fix that's required. In the case of CAE simplification, the CAE system needs a well-connected, good quality model with well-defined surfaces. Okay. Also, the CAE system requires a model of the appropriate level of detail. So as you can see here, the left-hand model is the original one, and on the right-hand side, we've used CADFix to remove holes and join surfaces together. Sorry, I was just muted for a moment there. So the tools we've got available in CADFix are collapsing edges, collapsing small faces. We could join edges together, we could join groups of faces together, join coincident solids. We can also split things, so you can split the solids into meshable chunks. We can split complex faces into better regions for meshing. And we've even got specific tools for splitting faces ready for shelling and CFD meshing. We can remove holes in faces, we can remove holes in solids. We've even got filters for determining whether we only want the through holes, blind or complex holes, and we can also filter on size and shape as well. We've even got the ability now of selecting a hole and converting that into a body. This gives us the ability to turn a hole into a solid, so we can do the CFD analysis of the flow through an object. Then we've got a feature removal tool. So if we was to manually select things like protrusions, fillets, bosses, we can then tell CADFix just to remove those features direct from the model. We have internal body removal. So if we've got a tolerance there to specify a window size, we can determine what's visible and not visible from the outside, and those objects inside can automatically be removed for IP protection. We can also look at large assemblies and say, well, actually, we don't require small parts, so we can remove these small parts or just turn them into bounding boxes. Also, if you're doing some analysis of a model, we've got imprinting available, so where, in this case, where objects are touching, we can imprint one object onto the side of the other, just to ensure that the meshes match up. Finally, we have another derivative of CADFix called Cadfix PPS. This is a package that allows us to specialize in reducing the file size of models. So we're looking specifically about getting the file size down as small as possible, whilst maintaining the visual appearance of the model at the same time. Okay, and this comes with a very easy to use, simple interface, which is really developed for non-design users. So in this case, we have a situation where people are designing products, so it could be a skid or a generator, and these have to get transmitted inside a process plant package, and they're finding the design models are just far too heavy and too many megabytes for these downstream systems to use. So we're running a system just to scan the model and reduce it down to its basic constituent parts. So if you want to have a look at Cadfix PPS, we do have a free evaluation going on at the moment. You can download this from our website, and I'll show you the web addresses on the last page of the presentation. Okay, so let me just flip over to CADFix and I'll show you CADFix working. Okay, so on the screen at the moment we have CADFix showing up. So you can see on the left hand side we have the wizard. So the first thing I'm going to do is open up a step model. So you can see here the different file imports that we have. So I'm just going to check this part and then choose what I want to do with it. So I'm going to choose Creo 4 and I'm going to choose a native file to send it out to. Now with this model I want to import it, prepare it and export it. So I run the wizard now. So CADFix is now importing the model and you can see it shown in the background. I mentioned earlier about the connectivity view where we want nice green edges. You can see from the key on the left we have some red edges showing up. And you can see these in the model. So the question is why have we got an error in here, why hasn't CADFix fixed them? Well, let's have a look at the first problem. So we have 7 poorly connected edges. If I select those, CADFix automatically selects them on the model. Then I can just zoom in and frame on them. Let's get a better view. So I was expecting CADFix to repair this top area. So let's make a measurement just to see how big it is. So the largest part of this feature here is 0.02 inches. If I go back to the wizard, you can see that CADFix has assigned it a tolerance of 0.01, which is smaller than that gap. So what's happened here is CADFix has looked at the model and analysed the model, and it said anything it finds less than this tolerance it would assume is safe to fix. Now we can actually specify a tolerance exactly as we wish. So we've got a situation where we've got these 7 edges. Now this is either a hole in the model or it's overlapping surfaces. So if I just shade it, you can see there are holes in the model. So I'll select these edges and down below I have a list of tools available that I could use for fixing it. So in this case I'm just going to collapse some points. So I'll collapse this point to this one. I'll snap the edges together, and where necessary it will join the edges back together. You can see now that my connected edges, poorly connected edges, has reduced down to 4. So I'm going to frame on this again, and we've got the next section, which is a large missing face. With this, I'm quite simply going to just build a new face on there, telling CADFix to recreate a new surface. Okay, so it's shown us the surface now. I've got an option of accepting or rejecting it. So there's my model. All the red edges are gone. There's still one outstanding problem. That's that the faces are joined together, but they're not actually been determined to be a body yet. Now CADFix knows it can fix this automatically, so it's offering to go back to the wizard and continue, which I'm going to say yes. So CADFix has rerun the repair on the model, and we've now got a solid. It's now run the prepare stage, so it's prepared the geometry for export to Creo 4, then it's exported the file for us. Now if I show my files, you can see here this was my original file, and I've now got my Creo file at the top here. Thanks, wrong one. I've got my Creo file here that's been exported. So I'm just going to save this model. Now, if I was going to take this model out to some sort of CAE package, you may want to do some further work on it. So first of all, let's remove this big chamfer at the top. So I'm going to go to the interactive tools, choose defeaturing, and remove chamfers. Now, with all the CADFix tools, we've got a size we're going to filter the part with, and then we've got a tolerance for the repair. So if I just click find, it finds this chamfer for me, and fix will remove the chamfer. So we've got this find and fix methodology that we're using with filters in place. So this enables us to scan a model very quickly to find features that we're after removing. We don't have to use that. We could also use our interactive selection tools. So I'm going to use my fillet finding tool here, just to automatically select that fillet, and I'm going to use my feature removal tool to remove that fillet. Now that's removed. Now I also noticed on this model, if I zoom in on this arm, there's some small slither faces. And let's just measure this to see how big it is. So that's 0.008 of an inch large. So I'm going to go back to connectivity view just so you can see what's happening. And I'm going to use my join tool now to join the slither faces together. So I'm going to look for any faces less than 0.02 wide. So again, Cadfix scans the model, and it's identified some faces that could be joined together to remove the slithers. At the bottom of here, we have the repair options that have been set up. I'm going to let this just run as automatic, and we've got a tolerance here. So this is saying that Cadfix can repair the model as long as the surface doesn't change above this tolerance. So let's zoom in now again on this slither, and then I'm going to run the fix. Now Cadfix found 31 faces, so it's going to run through all 31 cases here. So in each case, what it's doing is looking at the slither, looking at the faces that are joining it, and determining the best type of joint it can do between the two. And you can see most of these are coming up as a surface extension, which is a really good option. On the left hand side of that, on the column the entitled change, this is showing us how much change there is on the surface between the original and the new surface that's been created. So we can be confident that we're not moving the model too far and deforming the model. So again, when I shade the model, you can see there that the slivers have gone. However, on the right-hand side here, you can see there are some that are left behind. So let's remove these by using join edges. And again, I'm going to go to connectivity view so you can see the changes to the model better. So let's go to collapse edges. Now with a collapse edge tool, let's just measure this gap. So we're looking at 0.029 of an inch. Let's put this up to 0.03 of an inch. And tell Cadfix to find any edges that are less 0.03. So you can see we have some on this right hand end, and also at the other end there's some very small edges that are less than that size. Now the red globe you can see represents this 0.03 tolerance. This gives us the ability to keep some perspective on the size that we're using. I'm going to zoom back on this end again so you can see the effect, then just run fix. So the movement on the model there, Cadfix has worked it out using the automatic option. So this is looking at all the movements that could have taken place and applying the one that's going to be least disruptive to the model itself. Because again, we want to maintain the geometry as much as we can. So what else can we do with this model? Let's also have a look at some faces on here I'm not going to do them all, but it may well be that you've decided that you would like some of these faces to be joined together. So again, using the tools on the right here, I'm specifying I want the faces joining, and I'm giving it a tolerance to work to, and it will just automatically join those faces together for me. So doing this method, we could spend some time and simplify the model, removing the features such as chamfers, fillets. Okay, now if I wanted specifically to remove these fillets here, I could make a selection and again just use the feature removal tool. Right, I'm happy with that model as it is, so let's export it out to step this time because it's going into our analysis package. So I go back to my wizard, I choose step as my output format. I'm going to get it to rerun repair just to scan the model to make sure I haven't broke it in any way. Prepare it for going out to step, then export the model. So this is just rescanning the model. If there's nothing that needs fixing in the model, it will leave it as it is, move on to the prepare, then look at the underlying surfaces. So that's a typical case of simplifying a model for CAE. So let's have a look at a slightly more complex model. This one's a Creo model. So again, the model opens up in the background in connectivity view. Let me just shade it so you can see what the model looks like. And you can see this is an engine casing from a small engine. So again, if you wanted to just remove some fillets on that, very easy, just select those and remove them. Okay, if I wanted to remove the holes in this case, let's go down to holes and protrusions, remove holes in bodies, and then I can identify all the blind holes shown here in purple, blind and through holes, or I can say any hole, any cross section at any size. And it's important to note here we have an option for leaving a scar, so it may well be that we want to remove all the holes, but the downstream system will need to know where the hole was and that there was a hole there. So this would just leave a circle in the original face. So I've identified all the holes now, and I've decided actually I don't want to remove the large blue hole in the middle. So I can deselect that, pressing the wrong buttons. So I've got the red and the blue holes, it's red and the purple holes showing, then I can simply remove those. Now again, because we're going out to CAE, we might want to look at a couple of other features in the model. So let's look at collapsing sharp corner angles. Now a sharp corner angle, let's zoom in on this area here, is a case where the model or a face on the model goes down to a very sharp corner. When someone is trying to produce a mesh on this face, the mesh gets smaller and smaller and causes problems in this area. So we have a range of tools for dealing with this. Now, so I've got two at the top here, two at the front, and two lower down here. So if I look at these ones first, in actual fact, the easiest way to get rid of these would be to collapse points. So I'm just going to collapse this point to here. And again, you see it just removes that feature altogether. And there's the same on the other side. So I'm just going to collapse this point to here. This is probably actually an artifact in the model. I doubt whether it was designed in. Now again, if we'd use the sharp corner angle to find the other sharp corners, let me do it in the shaded view. In this case, it will be easier for you to see. So you can see the edges going into a very sharp corner. I can specify a step back size and simply fix the model. So this draws that surface back to make that angle wider. So as long as this is within the tolerance of your meshing that you're using, this will reduce the complications in these areas. And you can see at the front of the model, there's the original model and there's the model where it's been drawn back. One other thing I want to do with this model, there's a piece sticking out from the top. Now this is called a protrusion, so I can quite simply just remove protrusions from bodies, same way as I remove holes, and remove that automatically. Now again, this can go out to step in exactly the same way. So that's exported successfully out to step now. Now I mentioned faceted models. If you get a situation where someone sent you a faceted model, so this may be a step model, or in this case it may actually be a CATIA CGR model. I want this into Creo, so all I need to do in this case is to choose Creo and choose a Creo view as my subformat, and in this case we don't need to repair or prepare the model. I can just import it, then export it back out again. So it's just written in the model and then exporting it. Okay, so that's the original model. Again, if I go to my file viewer, look down my tree, I can see here that there's the compressor housing as a Creo view file, and the original one is just above it. Okay, so let's have a look now at the IP protection. So let's open up a gearbox model. So this is a typical case where we have a model with a large number of entities in it. There's 178 in this model. And we've got the model now, and you can see inside it there's a large number of gears and shafts. And the case on the near side I've made transparent just so you can see what's happening inside the model. Now also at the top of the model there's a hole which you can see the gears through. So let me just measure this hole. So this is 0.61 of an inch. So if I now go to my interactive tools, defeaturing, remove internal features, I can specify the hole size at which Cadfix will ignore. So if I make this smaller, it will be able to see through this hole and it will see the gears on the inside. So this is just a little bit bigger than that. So Cadfix simply finds all the objects that are hidden inside. Just takes a few moments to do the analysis, and you can see there it's shown all the internal objects, and I just run fix to remove them from the model. If I wanted to go a bit further, I can then do the hole removal. I'm going to remove all the holes from the model. And in this case, I want to see where they were originally, so I'm just going to tell Cadfix to leave a scar. So now we've got a simplified model where no one can see the original features that were inside. We also have options on the internal feature removal for removing all the internal faces as well. Now, let's have a look at one other option that may be of interest to you, and this is wrapping the model. So what we can do in CADFix, if you want, rather than a BREP model, if you want a faceted model or faceted representation of the model, we can create a shrink wrap. So I'm just going to put a size in here for my facets, 0.25 inches. Now CADFix is going to look at, again, the whole model, and then it's going to work its way around and convert this into a boundary representation, faceted model. So in this case, this may be used again for IP protection. It may be you want a lightweight model. It may be you just want some sort of space model available. So there's the model there. So if I was to reduce the faceting size, obviously the accuracy of the model will get better as well. So now for that part selected, if I want to send this out to Creo, again, we've got Creo 4 selected at the top. I can export it as a Creo view model. Then just export that straight out. And again, going back to my model view, we have the original gearbox, and then we have the Creo view files just above it. Okay, there's one more case that I'd like to show you, and this is the use of Cadfix PPS. So you can see Cadfix PPS is a lot simpler to use. It's got a lot simpler interface. So I'm just going to choose a step file here and import the step file. Now if I go back to my models on my disk, you can see that I have the pump shown here, the original step file, and you can see the size of that model. So this is a simple assembly. It may be it's a much larger assembly, internal components, and we have a list of tools that are very simple to use that enable us to manually go through and simplify this model. Or even simpler, we have the auto simplification. So I've determined that this component at the top needs to be kept because it's important for the fittings that go onto there. I've selected the middle simplification option, then just press apply. So Cadfix is now looking at the model. It's finding any small bodies that are less than a tolerance size, removing those. It's finding any holes that are less than a tolerance size, removing those. It's then looking for any protrusions, removing them. And then it's also looking at any parts of the body that can be simplified into cubic shapes or cylinders. So you can see in this case, it's done a good job here of making a very simple representation of the model. And again, obviously, we want this to go out to another package. So I'm going to choose step again. So it very quickly exports the step file. So this was the original file highlighted now. This is my new file, and you can see it's taken it from nearly 7.5 megabytes down to 0.2 of a megabyte. So significant savings with file size. Okay, well that's my demonstration over with. So I'd like to hand back to Nicole, who will finish off for us. Thank you very much.
At this time, we'd like to open up for questions. So if you have anything you'd like to say or like to ask David, you can use the question section of GoToWebinar and type that over, and we will take a look at that and make sure that you get your question answered. So far, we're not seeing anything come through. So if you have anything that you think of at a later date, feel free to reach out to either ITI or Boundary Systems. We're happy to help at any time with any of the things you've seen today. And at this point, we're going to conclude our presentation. Thank you for joining us today, and enjoy the rest of your week. Thanks so much.